Welcome, software engineers, to day 7 of CSC 222 software engineering. Before we review a couple things, let me just tell you something. For some reason, when I was laying out the course, I'm a little bit off because of Labor Day. I like to think in terms of day 1 and 2 as week 1. Day 3 and 4 is week 2. Well, okay, so now we got all off. So is this, it's the 4th week of classes, but we didn't meet that one Monday, so it's just day 7 here at the end. So things are offset a little bit. Just keep an eye on the due dates on Blackboard, and please let me know if there's something that says 2024. Today, if you're wondering where we're going, I do want to talk about homework assignment 7. And I want to say some general things. I want to give you the opportunity to ask questions about requirements and specifications. And then near the end, for those of you, some of you have already done it, some of you feel very confident about doing that, I'm going to let you check out. And anyone who wants to stay here, I want to go in and develop some code and take a look at a couple things in the context of Visual Studio so you can see at least how to begin assignment 7. I think most folks are caught up now. You have a good understanding of the running total design pattern and then that idea from assignment 4. But don't let off the accelerator. We're going to keep pushing through this whole concept, this add numbers individual project, until about halfway through the semester when we switch to doing a team development project. Let us review. On day 10 of this course, we will have exam number 1. Exam number 1 will happen online, not surprising. It'll be a Blackboard exam. You're used to those things from the quizzes, so that won't be a problem there, but I want you to know that's coming up. So anything that has been emphasized in the text, anything that we have discussed multiple times, and things that are in both the text and our discussion are certainly fair game. And I've told you this before. This is an exact question that you'll see on the exam. Define software engineering. I want you to begin here, but this is not the ending. This is just a way to get started. It's always good. I always hated those questions that I just had no idea. And I hated to make stuff up. So here you go. Begin with this, but don't stop there. Explain what management means in context. And what do we mean by software development? And why are we doing that? And what's the process? And how do we control that process? So, software engineering? Yep, I'll ask you what it is. Boss. Wear this biosensor so management can monitor your health during the day. Wow, I didn't know you cared so much about my health. Oh, I do. Employee 479 doesn't have shallow breathing. You can give that one some more work. If we haven't been introduced to the red fuzzy creature there, that is a cat. That is Catbert, one of my favorite characters in Dilbert, because Catbert is the evil director of human resources. And I think that's very fitting. In addition to defining software engineering, we've been describing software engineering. Computer science, the 2-word short definition of computer science is problem solving. Well, software engineering is part of computer science, so I throw an adjective in front of that. Software engineering is professional problem solving. Careful, this is a description. This is not a definition. Many things can be described as professional. Many vocations and careers could be professional. And of course, in many different jobs, you're solving problems. So this is a description, not a definition. But what I've asked you, if I can share with you, are some aspects of professionalism. So over the course of the weeks, and again, I'm off a little bit, but so this is our 3rd aspect of professionalism after being dedicated and being civil. Last time we introduced this, I want to say a couple more things today. and then we'll just leave it. It's interesting. I had a student here at the Mequon campus come to me because they went to interview at, we have a large insurance employer in just north of us. It's called Acuity Assurance, and they're a great employer, great benefits, great pay, just a great place to, great place to work. But the student came back and said, you know, the interviewer asked me a strange question. In addition to all the technical things, the interviewer asked, so what would you say makes a professional? And the student says, wow, I'm sure glad I can remember a couple things on your list, because the interviewer sat back and said, you know, I very rarely have an interviewee who can answer that question with any depth at all. So maybe someday this will help in your interview. If not, aspect of professionalism. Being punctual matters, at least in today's Western societies. I won't jump into this link. I should jump into the other one. Being on time every time conveys far more than just a good sense of timing. Tells people you're on top of things, you're organized, you can be counted on, and that you value them, the other person, and ultimately value yourself. Yeah, when you can't start a meeting on time because you're waiting for a person or two, we're just wasting everybody else's time there. So being on time, yeah, it's a mark of a professional. Now, we all know that every once in a while something happens. Last night, I was asked to speak in downtown Milwaukee, and it's always kind of an interesting situation. I hate traffic in Milwaukee. Milwaukee's not a big city. I love going to Chicago. There are 10 million people in Chicago. It's kind of like LA. And driving the I-405 in Southern California never bothered me. Same with Chicago. Driving I-94 in Chicago, wall-to-wall traffic, crawling, that just doesn't bother me. But for some reason, driving through Milwaukee, there's only 500,000 people in Milwaukee. Why are they going so slow? Sorry. So I said, wow, I really want to allow myself enough time. And I over-allow? I mean, I was there 45 minutes early, but that's okay. People appreciated the fact that I was able to begin my presentation on time so they could get the heck out of there afterwards. Sure. Really, it's to value other people and certainly to show that you value yourself. I'm sure you've seen articles like this. This is a catchphrase today in business. 5 minutes early is on time. On time is late. Late is unacceptable. That's the current catchphrase today. People say, well, why do I need to be 5 minutes early? It's because if you just walk in at the very beginning, you know what it's like. First of all, you got to sit down. You got to pop open your laptop or fire up your tablet or take out a piece of paper and et cetera, et cetera. So being there a little early allows you to get configured and get focused and ready to rumble. Oh, this is CNCS3. CNCS3, Christianity and Computer Science, the third assignment, which you'll see online at Blackboard. Remind me, I got to jump into Blackboard. We just have to look at it there. It's going to ask you to consider this and think about the relationship between the third commandment and being on time. Homework assignment 7. And yes, if you're looking for 5 and 6, they're not there. It's going to be easier for me just to leave the numbers that I originally put up there at the beginning rather than having to reset those, because then Blackboard just goes bananas. You know, that's really just an excuse. I really should figure out how Blackboard really works. The problem is your incarnation of Blackboard at Irvine is radically different than the incarnation that we use here at Mequon. You're using an older version, which is perfectly sensible because Next semester or next year, you're going to use a new learning management system. So why change it? But there's been some radical changes, and trying to reset my brain to do that doesn't work. And you know, the other interesting thing, different browsers behave very differently in the context of Blackboard. That's strange. Many of you use a product developed by the Alphabet Corporation, that's Google. Use their browser. I don't. At work, I use Firefox, and on my personal machines, I use Brave. And there are some distinctions and differences between the two browsers. All right, enough of that. You know what? Let me jump into Blackboard. Let's take a look at assignment 7, because what I really want to do is I want to ask you if you have any questions about the requirements or the specifications. If you have design and implementation questions, that's for the end of today. But we want to make sure, you know what I should check? Okay. Assignment 7, due 9/17. I originally had it due Friday, and then I decided, well, maybe an extra day would help there. Let's see what's CNCS 3, CNCS 4, quiz 3. Okay, you can see this, right? I have Blackboard set to so-called student preview mode, so you ought to be able to see everything like this. And under this to-do heading down there, you should be able to figure out when things are due. You can also tell, of course, by going to the content link, and then any of the assignments that are there, if you select them, it should tell you the due date then also. The way I'm attempting to lay out the units is to begin each week, we're offset now, with the text reading, and then the 2 days of that week, and then any assignments sort of where they fall. And then at the end of that week is the quiz, but of course that quiz is over that week, so you're really not doing it until the following week. Yeah, confusing. So just take a look at when things are actually due there. So we are in the midst of week 4. Here's the text reading for last week. Here's the quiz that you'll be thinking about this week for the material last week. We're in week 4, offset because we're beginning it on Wednesday and ending it next Monday. All right. Assignment 7. Oh, what? Why does it say Friday here and Saturday there? I have no idea. I got to look at that too. Let's take a look at the requirements and specifications. First of all, this is going to be built upon doing everything in the first sprint, and that's these things here. You have an input field with the current weight of the shim, an output field with the running total of the weights. What we're inputting is ultimately a weight of that metal shim that's being created there. And these are the functions that we asked for in the first one. First of all, it can accept real, that is floating point values. Don't limit it to integers. Use the enter key to perform the add. The user should be able to click the button, but the user should also be able to press the return or the enter key. Trap all input errors. User types in an A, that should be trapped. Don't error out to the operating system. Produce a correct running total, and then a clear / whatever you wanted to call it. I should just pick a term. Clear or reset, which allows the user to begin a new batch. So that clear button would zero out the running total and allow, so from now on, what the user types in is a new batch of shims, if you will. So here's the new things. So what are the new functions? First of all, output the total number of shims. So there'll be 2 output fields, the current running total of weight and the current running total of count. Keep the focus, the cursor, in the input text box. When your app begins and when you're doing things, that cursor, that focus should be in the input text box. Don't make the user click there. Now, in addition to the clear and reset, which gets rid of everything up until that point, you're going to add an undo. That removes just the last item entered from the running total, and of course, reduces the count by 1. Add a menu. You need to figure out how to add a menu to a form. That's a form property. Don't add a button. Add a menu. Search for that and do that. Nothing in the menu needs to work. And the only item you need to have there, you can have more, it's okay, is something that says help. This was also in 1, but I know some people missed it. Choose a good name for the form and display it. It will be displayed automatically, but give this a good name. The form name is fundamentally the name of your app, conveying some aspect of the purpose of the app. And this is different. Before, we had our try catch bring up a message box. Now I want you to output on the form itself. So there are 3 output boxes: running total, count, and now where the error message will show up. You may need to revise your UI. As we pointed out last time, you might use the add button to logically divide the input from the output area. Last time I showed you mine, doesn't have to be exactly like this. Here's a possibility. Now that you've seen it a couple times, seen the assignment, thought about it, do you have any questions? Feel free to unmute and ask or pop it in the chat. Any questions on the requirements, specifications for assignment 7? Oftentimes, questions really boil up to the surface as you're trying to design this or as you're trying to implement it. It's one thing to say, undo. It's quite another thing to actually design and implement that. But I don't want to deal with the design implementation questions right now. You just, first of all, you need to know why there's a problem, requirements, and secondly, what are the inputs and outputs? Here they are, that's specifications. All right, something comes up, feel free. I mean, if it's later today, suddenly you think of something, it's okay. Go ahead, you can ask. Let's review the major phases of the software development lifecycle. The SDLC is the framework. It's how we're doing our job. It's the process. Gosh, this is such an integral part of software engineering, isn't it? I bet if anybody was going to define software engineering, they'd probably want to mention something about the software development lifecycle. Yeah, good idea. Well, we've talked about this, the requirements phase. Fundamental question, why? Why is there a problem? Why is a computerized solution needed? You got to know the why questions before you can begin to tackle anything else. Last time we previewed specs, and we'll finish that up today, talking about some details of specs and some examples of that. The fundamental question in the specifications phase is what? What does a good solution look like? What are the features and functions? Computer science-wise, requirements is all about getting the outputs, figuring them out. Specs are all about the combination of the inputs and the outputs. And don't forget, inputs is not just data, not just that box there. It's also commands. That's input also. The third major phase of the software development lifecycle is design. We'll investigate it in depth in the second unit of this course, but we've been talking about design sort of hand in glove with implementation. You saw that handout in Blackboard about the running total idea, that so-called design pattern. It's at design when we think about how. And I'm going to encourage you, and I know Professor Tallman does this too. Before you start throwing code at you're saying, okay, I got to undo. Let's throw some code at it. Design it. Write it down. Do you use graphical techniques like discussed in the text? Do you write PDL or pseudocode? Do you have your own little chipmunk language? Whatever it is, you got to design it. Starting right away with code makes life really difficult. Design first. And we'll talk about that in depth later, but I think you intuitively understand that now. We'll just give some better tools and techniques when it comes to design later. Okay. Dilbert, I can't start the project because the user won't give me his requirements. Start making something anyway. Otherwise, we'll look unhelpful. So our plan is to cleverly hide our competence. You think too much. You cannot begin the process without understanding the problem and gathering the requirements. This is how I fooled you on day one. I said, we got this horrible problem. We got to add numbers. Go do it. Well, we didn't have all this ground rule. We didn't have all the ground rules. We didn't really know how to do it. Now, when it comes to actually doing the front end of software engineering, that's the requirements and specifications. This is all about communication. We, the developers, the software engineers, we create the documentation. So when we talked last time, last week at requirements and this week about specifications, we are the ones creating the documentation, but we don't make it up. We create the documentation based upon the user's input. Software engineering is all about communicating with the client and the user. There's no way for you to figure out or read the user's mind. You're going to have to communicate with the user. All modern software development life cycles, everything produced in the last 10 years, has the user as an integral part of the development team. You're saying, how can a non-computer scientist, a non-software engineer be an integral part of the team? Because they know what the problem is. They know what a good solution looks like and does. And when they're part of the team, it's easy to communicate. This is something I emphasize in my other classes. How are problems solved? In general, but specifically in computer science, problems are solved by the communication of information. User needs a running total. We need to communicate that information, that output, the running total, to the user. That's very simplistic, but you can see how this applies to larger projects also. These long ones are just a chance to stand up. Alice, I need to know your requirements before I start to design the software. First of all, what are you trying to accomplish? User, I'm trying to make you design my software. I mean, what are you trying to accomplish with the software? User, I won't know what I can accomplish until you tell me what the software can do. Alice, try to get this concept through your thick skull. The software can do whatever I design it to do. Can you design it to tell you my requirements? Software engineers think this is funny because sometimes interacting with users, they really don't know either what they want or need. But that's where the burden comes on us to try to dredge that out. Yeah. Let's talk about teams. When you take a look at the reading for this week, you'll notice that I write in there about teams. Why, you wonder? It's because today, modern software development is done in teams. Gone are the bad old days of one lone ranger creating software. The only place where you may see that today is in your favorite app store. You know, the app that makes bodily noises or something like that. Yeah, that's a possibility. But we're talking about, okay. When we're talking, I was going to say real apps. I shouldn't do that. When we talk about significant applications, business applications, professionally developed applications, I'm an old guy. When I worked in industry, and that was in the last millennium, I worked as part of a team. I'm not aware of anybody. I mean, I ask my students all the time who are out there doing it. The only people who work alone are interns, mainly because most companies don't know what to do with an intern. Sit in the corner and look at this code. Okay. Yeah, right. But when you are a professional developer, likely you'll work as part of a team. Let me give you a little generalized background to the organization of teams. And we'll talk about things that will ultimately apply to software development teams and things that will apply to you directly once you in CSC 222 start working as part of a team. There are lots of different ways that you can organize a team. Interestingly enough, in the New Testament, we've got lots of insight into the organization of Jesus's team. First of all, when you hear the term Jesus disciples, a lot of people think, oh, Jesus had 12 disciples. You know what? Jesus had hundreds of disciples. Yeah, read about it. There were large crowds, and they weren't all men. There were women also. Large crowds of hundreds of people followed him all the time. Now, of all those people, and you can imagine, if you needed to communicate to 100 people, that'd be a little difficult. So Jesus definitely had the inner 12. But when you read carefully the Gospels, you'll notice that inner 12, there was also leaders of subgroups, and there was an inner 3, wasn't there? So lots of times we think, oh yeah, a team is just a bunch of people. A team is not just a bunch of people. It's a bunch of people with organization, coordination, communication. Hey, you know what that is? Management. Software engineering is the management of the entire software development process, including teamwork. I suppose that there weren't any advantages, people wouldn't do it, or would they? What are the advantages of team approach to doing anything, and especially software engineering? Well, let me give you a couple, and then I'll see if you have some other ones. Usually I hear some really good examples. Here are just the canned ones. The advantages of team approach. A famous quote from someone you wouldn't expect you to know. It was a former president of the United States, even before I was born. The quote goes like this: I not only use all the brains I have, but all the brains I can borrow. That was uttered by Woodrow Wilson, 28th president of the United States. And thanks for thinking this, but no, he wasn't the president when I was born. But this is a great advantage of teams. Yeah, different people can have different ideas. Different people can approach the problem differently. People can analyze differently. People can synthesize differently. So one brain is good, Multiple brains, better. Oh, shoot. I said I was going to have you. Anybody think of any other advantages of developing software in teams or maybe working in teams in general? You certainly may unmute, or you could post something in chat, or you can all pretend like I never asked the question. Thanks for playing along. Thank you, Benjamin. Yeah, not only do you have more brains, but you have that diversity. I know I'm guilty of this. You're thinking about a problem and you get locked into one perspective. And then somebody else looks at it and says, well, did you think this? Wow. Good idea. Yeah, diverse opinions. Good one. Any other examples? Yeah, exactly. Thanks, Kyle. You can bounce ideas off. The brainstorming session. Sometimes you just want to throw something out there. It helps you to say it, and it certainly helps other people to hear it and reflect on parts of it, sort of the back and forth there. Andrew, thanks. Yep. Wiser yeah, you bet. Right. In many good companies today, you will be mentored. You'll be connected directly with an older, wiser person. Hopefully not somebody as old as me that you have to keep wiping the spittle off their face. That's not very fun. But there are folks who have learned the ropes and they understand the corporate culture and they've done software engineering and they're very willing to share that with you. And then the flip side of that is, yeah, at some point in time, you'll be that person. And maybe you'll start as that person because there might be a member of the team that, doesn't have this great degree from Concordia University, Irvine in computer science and really is not as adept as you are. Wow, those are good. Any others? Advantages of teams. All right. Any disadvantages of teams? I've got some, but since we're in the mood right now, yes. Let me know, what are the disadvantages of teams? You don't get your own way. Yeah, there's got to be some give and take. Yeah, thanks, Ryan. There may be misunderstandings. Absolutely. We're going to talk about this later today, that English is imprecise and communication, sometimes you can be misunderstood. Hey, I don't get it my way. I could be misunderstood. Yeah, oh man, Brian, good one. Not a uniform coding convention. We're going to discuss that. Yeah, we got to get that one set. Kyle, battle for control. Tamsin, everyone may not contribute the same. Now you're thinking about academic team projects, aren't you? Group workers versus individual workers. Yes, exactly. As a former student, wow, working in an academic team with other students was always challenging because not everybody carried their weight. Yeah, Kyle, you're right. Difference in worldviews. I mean, they may have a totally different perspective on lots of different things. And now how can we mesh and mold and norm into an actual productive team? Great question. Thank you for those. Yeah, you're absolutely right. The classic ones identified, especially in software engineering, and a couple of your ideas touched on this, is the ego of the team members. Hey, I didn't get my way. Hey, I want to be the boss. Hey, that's a stupid idea. The ego of the team members. This is one that is, we all intuitively sense it. We're just not sure how to frame it. We're going to be reading an article and talking about this communication overhead. The more people on a team, the harder it is to communicate and communicate well. And in addition to that, just being in a part of a team means there is some overhead. You can't be, quote, working on the project if you are communicating with another person. This is something that is known in software engineering as Brooks' Law. I'm going to have you read an article by Fred Brooks. It's an old article, but everybody talks about it today. Brooks' Law. This is Fred Brooks. Now you've seen somebody older than me. Fred Brooks is Professor Emeritus of Computer Science at the University of North Carolina. Yeah, the big one at Chapel Hill. He wrote a classic and foundational article in the 20th century called The Mythical Man Month. I'm going to ask you to read that article, and I'll tell you when. I think you might actually be able to see it now, but then later we'll think about it a little bit. The Mythical Man Month deals with this problem of communication overhead. So without getting into it right now, you'll see the article online. And just take a look at his major points. And let me use this diagram to illustrate it before you even read the article. 2 people in a team, 1 line of communication. Okay. By the way, the 4 is wrong. I was going to draw my own and I found this online. I said, hey, I'll do it, but the 4 is wrong. 3, what's wrong with this? Well, you need the diagonals filled in also. Right? So A could talk to B, A could talk to C, A could talk to D, A could talk to D and C, or whatever, lots of ways. 5, you see what's happening here? The more members of a team, the more communication explodes. And that communication overhead leads to something that we identified today as the mythical. Okay, Brooks said man month. We'd say person month, but you all understand what they mean. This article morphed into a book, morphed into several revisions of the book. This is the anniversary edition, published in the 21st century of Fred Brooks' The Mythical Man Month. So, big important thing, if nothing else, no undergraduates should leave college without at least hearing the name Fred Brooks. And even if you can't remember it, if somebody says Mythical Man Month, you'd probably, oh yeah, I remember doing something about that as an undergraduate. This is so common that you see it as within tech comics all the time. How long will your project take if I add 2 people? Dilbert, add 1 month for training, 1 month for the extra complexity, and 1 month to deal with their drama. But after all that, they'll be as useful as this meeting. Brooks' Law states adding people to a late project just makes it later. Adding people to a late project just makes it later. I won't spend time with this. I sort of alluded to it before, but read it in the text or in your religion classes. You may have discussed this, the lines of communication, how Jesus dealt with his team and the lines of communication. We had a couple of you said something similar to this. This is a famous quote from the Dilbert's boss. Teamwork is a lot of people doing what I say. The pointy-haired boss. Did I mention before, Scott Adams drew Dilbert's boss as bald with just 2 tufts of hair up there. Does it remind you of anything? It's supposed to look like something or someone. If you thought Darth Maul, you're close. Actually drew that to make it look like horns. So it's supposed to give you the impression of Satan, right? Yeah, the boss is evil, of course. I've talked about Scrum a couple times. Read a little bit about it in the text. But Scrum is a software development lifecycle. Scrum is a way to manage the software engineering process. Scrum has pieces of our SDLC. They talk about requirements, and they talk about specifications, and they talk about all these other things. What makes Scrum somewhat unique is this iterative process. It's both iterative in process and iterative in product. You don't build the entire product at once, you build it in stages or in scrums. And each scrum is called a sprint, whereby you take a portion of the requirements and specifications and you build a working product, even if it isn't the final shippable product. That's what we're doing with our individual project. There's going to be several of these sprints, several of these development cycles, creating more and bigger code. Scrum, yeah. Here's another way of thinking about it. So in a sprint, I know they all say sprint one, but it's just supposed to be, this is a sprint. And people use different terms: discover, design, develop. Discover would be requirements and specifications. Design would be design. Develop would be implementation, test, and then do it again. Discover more, design, develop, etc. So it's an iterative process. And that's what we're doing. So Zeb shared with his friend Zeke, Zeke, I was planning on a brain transplant. And Zeke said, yeah, so what happened? Zeb, I changed my mind. I changed my mind. The other thing I dislike about winter is it's really dark up here in these northern latitudes. I don't like that. All right. You'll find lots of the specifications in the reading for this week. So please avail yourself of it. I just want to do a thumbnail sketch. What I've talked about is with requirement specs and everything else is really not enough. It's just to set the stage so that you can read about it and then be set. Specifications phase. Oh, did we do the comment? Wally, I did no work this week because I judged the user's specifications to be inadequate. Should I continue to do nothing? Or do you prefer I use incomplete specs to produce useless designs? The next thing you hear is something called leadership. These first two, again, I don't know why I leave out 5 all the time. The first 2 phases of software development lifecycle are referred to as the front end of software engineering. Front end has a specific meaning for us. That is the combination of requirements and specifications. What do we do during the specification phase? We answer this fundamental question and its next related question. What does the product look like? What does the product do? These are what questions, specifications. They are not how questions. That's later. That's design. What does the product look like? What does the product do? The related question, and it really is just a little more computer science-y than the first one. What are the features and functions? What external user-facing features are there? What are the buttons? What are the boxes? What are the functions? What are the algorithms and data structures behind those outward-facing features? In a nutshell, that's specifications. How do we figure all that out? Well, what we need to do in the specifications phase is fully specify all inputs, fully specify all outputs, all inputs, all outputs. The focus of the specification phase is really on I/O, input output. Data coming in from the user in the forms of raw data or commands, and information that we generate in our app as information back out to the user. I'm trying to overemphasize this because what we don't do in specifications is we don't do design. We don't think about how that happens. We just want to make sure we understand what needs to happen. As with the requirements phase, creating a prototype is extremely useful as a communication tool. Prototypes don't function. There's no code behind anything. It's painting the user interface. Really easy to do and really easy to redo in Visual Studio as a rapid application development tool. Create the prototype so you can communicate with the user and ask, is this what you want or not? The other thing that happens during specifications we won't be able to do, we'll just have to talk around it, is a planning document. We need to estimate the time it will take to create this product. We need to estimate the cost of this product. We need to estimate how many people, and by people, I mean computer scientists, software engineers, developers. And what other resources might we need? Do we need some specialized hardware, etc.? This is all part of specifications. At the end of this unit, beginning of the next, we'll talk about how do you estimate that? How in the world could I even begin to figure out how much time this would take? We'll see. At the very end of the specifications phase, then, when you're doing the problem-solving model, a contract is produced. In other words, we say, we will create a product that has these specifications in this amount of time for this cost. So client, you give me this amount of money, and at the end of this time, I will give you the product that meets the specifications, the contract. We had too many of these. When we did requirements, I did this little thing from Genesis 6 about why there was a problem and what was needed to solve the problem. To review the requirements that we see out of the flood of Noah's day narrative in Genesis 6 through 9. Why is there a problem? The sinful nature of human beings. Right. What is required? Well, some kind of rescuing mechanism. In this case, an ark. Now, if you read in okay, so again, we read 11 through 14. We got the problem. We got the requirements. What are the specifications? When you read a little further in Genesis 6, we get, do I have it here? Oh, yeah, shoot. Now I got to go look it up. Ah, good. Here it is. Genesis 6, beginning at verse 14. God's specifications to Noah of the ark. So make yourself an ark. Notice a specific type of wood is specified. Make rooms in it. Coat it with pitch, both inside and outside. And this is how you're to build it. The ark is to be 450 feet long, 75 feet wide, 45 feet high. Make a roof for it. Hey, good idea. Finish the ark to within 18 inches of the top. Many people believe that was the windows at the top. Put a door on the side and have 3 decks. lower, middle, and upper. Here are the specifications. So we've fleshed out more of what this solution is. Now, could you actually build an arc from these specifications? No, you'd have to do design. And the Bible is pretty silent about the design of the ark, pretty silent in most aspects of the instantiation of the ark too. Many people think it wasn't just Noah, his wife, his 3 sons, and their wives that worked on the ark. Many people believe that Noah contracted with other people to work on it also. If you have a team, as long as it's more than one person, though, you can't just say, oh, hey, make 3 decks. You've got to have a design document. How tall is that deck, etc. Specifications, good idea. All right. No, you just read about that. You just read about that. Okay. I want to make sure I have enough time to answer any specific questions about instantiation, about actual coding in Visual Studio. I appreciate those of you that are using Visual Studio 2022. You uncovered an issue, and I'm pretty sure that is because, and this is my fault, I'm pretty sure it's because you added more potential frameworks than are really necessary. And then you had choices of things, and it ended up being multiple, Windows, Forms, app, etc. So I just today, as a matter of fact, I finally got my IT support to get my Windows on my Mac license set so now I can actually do some work. Okay. So this is what I'm going to say. Be sure to be in the happy habit of taking a look at Blackboard often. See what's there. Are you keeping up? Are you doing the readings? Are you doing the quizzes? Are you looking at the notes for the day? I guess the notes for the day is not as important. They're just, as I mentioned, just a coalition of the things in the text and maybe what I'd be talking about, although I usually skip around quite a bit. So be sure to take a look at these things online and note when things are due. And this is what I want to say. What I'm going to do next is I'm going to jump into my Windows virtual machine, and I'm going to start the process of doing some code for assignment 7. For those of you that feel real comfortable with this, there's no reason to hang around. So let me say, first of all, to everybody, before anybody goes, thanks again for your hard work. Thanks for joining me. And I know it's a difficult situation. A lot of you are coming from a class just before this, which is much more exciting. And now you got to suffer through another one. It's just hard to do things back to back. And even if that's not the case, I mean, doing it at a distance, I know that's hard. There's all kinds of environmental conditions that need to be taken care of too. So for those of you that feel comfortable with assignment 7, you're dismissed. Have a great day. Have a happy weekend. I will see you on Monday.
Hello, Professor.
Yes, question.
I'm just a little bit stuck on the undo buttons.
Okay. All right.
Yeah, so I already submitted the homework, but the problem is I don't know how to do it, so I just check Google it, and the only way it show me is just use something like
Sure. Let me say in general, first of all, if you did already submit the assignment and you're picking up something right now, then feel free to resubmit it.
Yeah, okay? I know. So problem is just, and I think this is, it's just blah 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 and point undo. Yeah, like this.
Sure.
Yeah,
okay.
but the problem is it is only work on the text text box one, it's just the text box makes the user input. And
Okay.
there's also, and there's also works, there's also text box like the text box two for shows the number of streams. And so also one text box three is just means how many times it's added, and this is this two boxes not work.
Okay.
For the and for the text box three, I know I just make it is just make it as a -1. Right.
Okay. All right.
Yeah.
Let's that's probably a common question. So let's take a look at design of undo.
Yeah.
First of all, what undo means is undo means the last item needs to be eradicated. I need to get rid of it. Okay, we know that's good. So logically, undo affects two things. Undo affects the running total, and it affects the count.
Yeah.
Now, logically, you need to deal with this in two ways. First of all, think in terms of features and functions. You need to deal with it externally. So in other words, when the user selects undo, the undo button, okay, imagine that says undo. What the user what the user will see is count is one less.
Yeah.
And then the running total is whatever it is, right? One value less. Good. Now, that's externally. Internally, you'll have to handle that also. You're going to have a variable that is, I called mine count. And so when the user undoes, is that a word? When the user undoes, then you will decrement the count. Decrement the count. So let's think about it logically. Okay. So here's my method. I won't type it all in here, but here's my button for undo. Now, what we have to do, first of all, is the internal stuff. So what am I going to do? Let's say you called your variable running total.
Yeah.
So running total, we got to decrement it, right? So the question is, what do you decrement it by?
Just decrement this count for the last time, right?
Okay. Yeah, right. Don't put those together though. The running total is separate. Now, I had a variable.
User's input.
Right, user input, whatever. Okay.
Yeah.
So you update the running total, you get rid of the last thing that was input. Yeah. And now you also decrement the count. Right. Okay, good. I'm not putting semicolons. You're okay with that. And that's supposed to be, it doesn't look like it. That's a dash dash. I'm decrementing there, subtracting one from count. Now that I've done that, now what I need to do is I need to update my text box. So text box, I'm sorry. Well, okay. I won't do all the capitalization that I should, right? Text box 2.text. Let's say that holds the running total. Well, then I need to, do the convert. I won't add all this stuff. Now I need to update that. So running total, the display to the user used to show 2.73. And now after hitting undo, I put a new value in there. Just write it in there.
Yeah. Okay. Yeah. But this is just a problem because the user may change user may change the input in the number one in the text box one, right? Yeah. And I just try, but the problem is I don't know how to make it. Making the undo at first. I'd let the undo change the text box one at first. Then
okay.
Yeah.
For right now, don't worry about. Well, okay. In this problem, we do need to worry about text box one, but when the user selects undo, You don't have to, what you should do in text box 1. Okay.
Text box 1 is just read this input.
Right. Okay. Let me show you how to handle text box 1.
Okay.
Am I going to be? Yeah. By the way, have I changed my share? Can you see what I'm doing?
I mean, I only see your mouse.
Yeah. Can you can see the stuff from the whiteboard, right? You can see.
Yeah.
Okay.
Of course, it is all blue.
Yeah. Okay. Yeah. I'm
Xbox.
not doing any code. All right.
Yeah.
So now, oh, darn. Okay. I hate this thing. All right. I'm going to have to start over here. So this comes out. So now you're saying, what do I do with text box 1? Okay. Well, in text box 1, okay, I said I wasn't going to do all that stuff. In text box 1, 2 things to do. First of all, you want to put the focus there. There is a command for that. Okay, let me make this look more like real. What language are we working in again?
C#.
C#, yeah, okay. Text box 1. Here's the method. Focus. Focus.
Text box focus.
Right. What that says, text box 1 dot focus.
Okay.
What that does, and don't send it anything, just use the parens there. That will put the cursor in that text box.
Okay.
Now what you want to do is you want to wipe it out. You want to get rid of the contents of that input box, right? Okay, so there are a number of ways to do that. Here's one way. And the reason I like this way is because I think it's very sensible to what we are doing.
Yeah.
Okay, you see what I did? I
so it's just
wrote,
clear.
yes, I wrote a blank. That's going to overwrite whatever is currently in that text box. You know, the user typed in 5 or whatever. Now it's going to do that. You put this at the, okay, it should actually be a method by itself, but put that at the end of your undo. That will get rid of, it will reset both the count and running total. Put your focus back in the input box, wipe out what's there, and now the user is set. User said, great, wiped out that, ready to rumble.
Okay. Well, thank you so much, Professor.
You're welcome.
I'm just gonna try it this time.
Yeah.
And
Try
so,
it.
and how about the work? How about the quiz 3? When is the quiz 3 due?
I'm sorry, which one? I don't know why my
Quiz 3.
Okay, for not the clear and reset, right? Yeah, yes. Okay, so what the clear and reset will do is it will set your variables internally to 0.
Oh yeah, clear and reset. I already know. I just use just making the all the text box be blank. That's it. Correct.
Yeah. So you will internally wipe out the values and reset all your text boxes. 1, 2, and 3, set them to blanks. Put your focus in 1, and then you're ready to roll.
Okay, cool.
Yeah, good.
Yeah.
Okay, good. So does that help? Does that cover it?
Yeah, cool. Thank you.
Okay,
thank you so much, Professor.
You're welcome. Now try it again and resubmit it, and let me know if you run into problems. Okay.
Okay, cool. Thank you.
Okay, you're welcome. All right. Bye-bye. Okay, I guess everybody else is gone. Any other questions?
I think it's only me.
Okay, Frank. Yeah. Sounds good. Well, I'm glad you did that, and thanks for working hard. All right.
Thank you.
So work on that. Have a great day. I'll see you next week.
Yeah, see you next week.
All righty. Bye-bye.